Okay, so let's start. I think most of people have joined. So, yeah, good afternoon, everybody. I hope all of you are doing well. Okay, so today we have Raj Tanawade, who is going to deliver a session on designing for VR and AR. Okay, now as we all know that world is being introduced to new realities. People often want to explore something beyond their imagination, and these new realities are driving towards that goal. The introduction of metaverse, NFTs, etc., people are more like to get into emerging worlds of VR and AR. So now today Raj is going to tell us about how the VR and AR are designed. Okay, so over to you, Raj.
Thank you, ma'am. Thank you for the introduction. So I'll just quickly jump onto the topic. So as per the introduction, so how many people over here are aware about the new realities that we are seeing? So like VR, AR, or any other thing that you are aware about? So and let me clear that this would be an interactive session, not like a person is talking to you and your people are just listening. I might ask you some questions, so I might be expecting some feedbacks. So if a few of you could please participate in, so that would be a very good session for everyone. Because there are some references that I have given in the presentation that you could relate to and that you might have seen before also. So that might help. So I'll just share my screen. Okay. So is the screen visible?
Yes, yes.
Yes.
Okay. So today we'll be taking this session for the considerations that we take for the part where we design for AR and VR. So firstly, we need to know what is AR, what is VR. So we'll go into that step by step. So if you have any doubts, any clarifications to do, we can do that later, or you can just ask me while I'm switching the slides. So firstly, we'll see what would be the outline for today. So today we'll be covering the extended realities. So that is the term that we use for AR, VR, MR collectively. Okay, so while you're saying that some people confuse AR and VR, MR, and AR interact, so they use it interchangeably. So while some might refer MR as AR, some refer AR as MR. So it is happening. So we'll get into that what is what. Okay. So then we'll consider what is VR and its design considerations, what is AR and its design considerations, and different aspects of AR and VR. So, and there's a bonus at the end. So we'll go into that. Firstly, what are extended realities? So currently we are living in a real world. So we know the real world exists. So the realities that are currently extending the horizons, like the AR, VR, MR, are totally termed as the extended realities. So AR, VR, and MR come under the umbrella of extended reality. So if you hear the term XR, don't get confused and don't confuse it with something newer that you think that might be worth three of this or might be an addition to this whole thing. So XR is collectively an umbrella that houses VR and MR and AR. Okay. So what is VR? So VR, as you might have known or you might have seen in the ads, PS4 VR or like Oculus, you have seen. Then we have Google VR, तो वो cardboard box आता है. So we have seen that it is a box type of thing that you wear on your eyes. Okay. So what does it provide? And it also comes with like headphones or like that you have to connect to get an immersive experience. So what it covers it. So the goggle that you wear, the VR goggle or the VR headset that you wear in. So basically that has a screen built in that is at a distance from your eyes where you can feel the experience totally. Sorry. So this happens inside the virtual world. So the 3D environment that you see in the virtual world is actually programmed using Unity or any other software that support 3D rendering and all. So you for gaming industry we use different avatars, or we could have a customizable character, or we could just see a movie inside it, or we could just have say a scene where we might want to go, but we currently cannot due to the physical limitation. So that is a 3D environment. that is a virtual environment that we can experience inside a VR. Okay, so as this is same, the same experience that we want, the experience, the sensations that we want, like in the real life, we may not be in a condition, good condition to take a hike to a mountain. Okay, so but in VR, if we want, we could just sit at a place or just have a VR on our eyes, and we just can explore the beauty of the mountain sitting right inside a house, so without any sweat. Then we have the use cases where VR can be used. So particularly VR can be used for employment training. So as you know, like some employment require intensive training for field works and all. So it is very costly for a company to like get to every employment training and train them on the fields especially. So that can be reduced. And then vehicle operation training. So as you know that some industries like the aviation industry is currently using Microsoft's virtual reality, where we can see the pilots who have been trained for flying the jets and all. So they are firstly given a simulator. So simulator they use it for understanding structure inside the cockpit, how it is, how it's going to be, where are the buttons, what would do what, and they are made to sit into a chair that gives them the entire realization that they are sitting inside a cockpit. It has the vibrations, it has the oxygen running out and all. So this whole scenario is covered. Then for surgical training, we can see that for surgical training, we might want to also consider the part where we don't want to cut bodies through day in and day out, so that we are consuming and decomposing a lot of bodies. So we could just eliminate that thing as well. For then for architectural modeling and various other things. Uh, Only we are aware about the part where VR is used for games. So along with games, these are the other things that where VR can also be used. Okay. So what is a VR setup exactly like? So there may be three setups based on what you want to do with it. Like a hyper immersive based emotion based setup where you could be having sensations like tactile feedback. Then you'll have the like water jet spraying on your face for giving you the feeling that you're gliding into a water park and all. So that kind of thing is a hyper immersive emotion based experience. Okay, so that is basically influencing your senses. So the sense of touch, the sense of feeling that you have, the aromatic fragrances that may be pushed around you to make you feel like you're sitting in a nature, like a water park or something, like so in a forest or something. So that is it. So for POV documentary, like we have lifestyle experiences for like we want to transport. As I said, we want to take a hike to a mountain, but we currently cannot. So that all can be covered in POV documentary. Like we want to take a tour of the museum that currently we are not able to see, or it is far away and we are not currently able to travel to the destination, but we can do that in. Okay. And last but not the least, we have the gamified experiences where we know that the particular aim of a game like a VR game is to shoot an enemy, or like you have other objectives as well. So that can be accompanied in as well. Then we have VR experience setups consideration. Okay, so as we know, VR experience setup considerations, we might want to take into consideration that we are wearing a headset on a head, and we might want to see that a lot of people are not used to wearing such a huge goggle on their heads on the head, and it is quite heavy. I could tell that by experience because I had tested some games in it. So VR cannot be used like for longer sessions. So because you might have like motion sickness and all. I have seen people get tired and they have headaches. They even have motion sickness and they vomit eventually, if that is more. But let's not get into that part. So first thing that you want to take into consideration is head tracking. So what is head tracking considering? So firstly, so you can see the axis X, Y, and Z axis. So what happens over here is, so while the headset is worn by a user, so you'll have to set a fixed point where the objects on the ground don't float around. Okay, so head tracking basically keeps the object stationary, although the person is moving around, or he's shaking his head, or he's yawing his head, whatever he's doing. The head tracking feature really helps you, and it maintains the sense that he's actually interacting in a real world, and that is not a virtual one. If any small misconceptions or anything happens in it, and the and it breaks the experience of the user, so that is considered as a flaw in the design, or that is not considered as a good thing while designing the VR. So there are a few guidelines that we want to follow. Like we want we if we can take the Google VR guidelines, Oculus guidelines, we have the IBM guidelines, and also Apple is also providing some guidelines for that. So we could take into consideration how that should be done, and how head tracking and how motion sickness could be prevented. Then avoid sudden changes. So for changes, so as we know that inside a virtual world, we are having a screen that is literally like 15 centimeters or 15 centimeters mostly. I guess 15 centimeters away from your eyes. And if you suddenly have like a dark sensation, and within a moment you have like a bright sensation, so that would create a lot of strain on your eyes, right? So and similarly, that experience, you could see that there is a lot of text in there. So you want to avoid the textual instructions. What happens is, so when you're having a textual instruction, so it is very lengthy, and the user is not able to read that, क्योंकि उसके नजदीक कितना 15 सेंटीमीटर की डिस्टेंस है, वो कितना रीड कर पाएगा. And that too, having such brightness and such contrast that he won't be able to read long paragraphs. So what we can do is reduce the textual instructions and make it like in audio format, or just we could just dictate him कि ये instructions है, and he could just go along and he could just follow along that. Okay. And this is the high-end VR setup. So this is basically a gaming setup. So you can see the person is wearing the VR goggles. That is the VR headset. That is the key to the entrance for the virtual world. And then we have the joysticks. Basically, the joysticks have the buttons on them like the PS4 controller, like Xbox controller, and these are used to control your interactions inside the VR virtual world. Okay, and this is a mounting station. So this does not come with a traditional setup of VR. The traditional VR setup only comes with the headset, and you get the Joy-Cons or the joysticks, and you can also opt for a headphone if you want to, or you could just get a wired one and plug it into it. So that can be done. And so what is this mounting station for? Like mounting station, firstly, inside a VR, if you're playing an extensively MMORPG, or like you're playing a open world game, see, and you're running around and you can't stay in one place, right? So if you're doing that at a home at your home place, and you might run around into walls. So this setup, this mounting station, allows you to just stay in a place and run on it. Also, it has a trackpad, or it has a treadmill kind of structure. So that allows you to just stay in a place, and you can run, perform any actions that you want, but that you're constrained inside that limited area of motion. Okay, so that is it. So I would like to ask, like, there is a movie that we might have seen, like the Ready Player One. Has anyone seen that movie?
Ravan it is.
Sorry.
Ravan, Shah Rukh Khan's
Uh,
Ravan.
Ravan can be a virtual reality. Yeah.
I have seen that, Raj.
Ready
I
Player
can
One,
see
right?
the
Yes.
recent one, a Doctor Strange of multiverse.
So I'll just focus on the part where we have Ready Player One. Okay, so Ready Player One, what it does is, so there's a person who is very acquainted to games and all. We don't want to go in the details कि वहाँ पे क्या हुआ था, what time they were living in, but they have VR headsets and a tactical suit. So what this tactical suit does is, so whenever you're inside the virtual world, you're wearing the tactical suit. Whatever the NPC, like non-playable characters, are doing with you, like they're hitting you, they're punching you, whatever they're doing to you. So what will happen is you'll feel the sensation on your body with that armor or with that suit, tactical suit, right? So and inside the world, it was basically for gaming purpose only, but that was a really nice representation, like how VR could change your perception to life and perception for the gaming and all. So that was a really advanced feature that they showed, like the tactical suit. So such a tactical suit is not yet developed, and it might take very long time for such a thing to develop. But currently what we have is the joysticks can give you tactical feedback with the help of vibrations. They have motors in it, just like the PS4 and Xbox controllers. So we could sense the tactical feedback. So that is how we can have an immersive experience. Like if you hit something, the controllers vibrate. If you aim something and you shoot a target, the controllers vibrate, and you get a sound also. So that is all it collectively gives you an immersive experience. Then what are the interaction challenges? Like, so firstly, as we know, the VR community and this whole thing coming into our life is a new thing, and some of us might have experienced it, right? Some of us are very new to it. So what will happen is, so currently people are used to the mobile phones, cell phones, laptops, tabs, and all. So we know how the interface works, right? So for VR, when consider it as a thing where firstly we are introducing the touchscreen mobiles to a grandmother, grandfather, something like that. So how fast can they adapt to that? So that is a consideration that we want to take, right? So such a case might happen with us. Also, the Gen Zs, the millennials, or whoever it is. So if they are not aware of about the VR, so they need to have a proper introduction to the VR set. Then we need to have comfortable user interactions inside it. Like you can see the VR hands that are shown. So this is a representation of the hands of the user. Obviously, your hands cannot be shown inside the VR world, right? So we have this thing. So this can be controlled with the controllers, the joysticks, and all. So when we click a button, you'll see that menu is popping out of his hand, right? For controlling and all. And using the second finger that is shown that's highlighted over here, you could just tap on any of these. Okay, so this is a very similar experience to something that we do on the mobile phones. Right? We have a hamburger menu, kebab menu. We click on it. We have it expanded when you click on the options inside, right? So something similar to this can be implemented. Or like if you want to do interactions, like we should give it like overhead or at a distance that a user can easily access to. क्योंकि VR के अंदर कैसा होता है कि you're holding the VR joysticks and a beam of light comes out of it. Okay, so you're pointing towards that thing and you literally want to aim it correctly. So you want to take in consideration कि उतना distance जो है the beam has to reach and the text should be readable, the interaction should be clear enough. So we should be able to design comfortable user interaction inside the VR. Okay, and then obviously, as I said, onboarding scenarios we should consider, like we are teaching a newborn. So currently we want to focus on the part where how the user would enter the VR. Like, so firstly, if you want, you could just create a character inside the VR, inside your program, that greets the player or the user while he's entering the VR, right? So there may be a portal where he'll be instructed that this is a 360 portal. And once you enter that portal, there might be a change in atmosphere and you could just see like 360 view and you could just go anywhere inside it. So that is some kind of onboarding experience that we want to show, like this is going to happen. Or we could just give like small tutorials inside the VR virtual environment, how it is going to do. And finally, as we know, so whichever apps we use, like any app you take, like a mobile apps, so we have a prototype for it before it goes into production, before it goes into development. So similar thing is implemented for VR as well. The design process remains the same. The first thing we want to sketch out what would be the screens like and how it would be. So this is something that we want to take into consideration. So firstly, so we can see that a person is standing over here, right? So with a distance of 1.5 meters. So this is the focal distance that you want to maintain. Right, so this is the field of view of the character of the user that is standing inside the VR, and that is the optimal distance that he will be seeing the objects at, and that is the straight screen, right? That is directly perpendicular to you, sorry, the parallel to you, right? So that will be at a distance of 1.5 meter, right? And then you can have the shared view, right? So दोनों side all the views आएंगे, like that may be something that because it is a curved display. So VR, whenever you see it is a 360 display, so it is going to be curved. So you'll have to take into consideration that we are viewing it at an angle of like 120 or so. So uske hisab se you'll have to design. And also when you're giving interactions, right? So यहाँ पे if you see, we have the overhead interactions. So you could see the live and VOD written over here. These are the personal controls. Then on the right hand side, we can see there is private message, mute, And these five circles are there. So these are the circles that you can use to change your positions inside. So this is one use case. So you might not want to use this similar use case because this is a very basic one. You want to just move around inside the VR, so that you can do. And then as you can see, the beam of light that's passing from the controller that the person is holding, that is pointing towards the menus or the option that we are providing. So the interaction is basically carried out in this way. And this thing that you see over here is something that is a rendered setup, or the render high fidelity prototype that is prepared for a game. So this is something that you can see. So that is all for VR itself. And do you have any considerations, like have you been in touch with any friend who owns a VR, or you yourself had an experience with VR and would like to share? So, or you have any doubts, then we can just go into it before we proceed to AR. Anyone? Okay, so we'll proceed to AR then. So AR, as the name suggests, or you might know the full form of it, augmented reality, is a technology that uses your devices like phones, the tablets and all that we have, and it overlays a programmed image or computer-generated image that you say on top of the real world. So that is how AR works. Like, so the very famous game that came recently, the Pokemon Go, right? So people were crazy about the thing. So people went distances for searching Pokemons and all. So there was a phase where people even had accidents with that interaction. So we'll have consider what points need to be taken into consideration for designing for AR and all. So firstly, as you might have got the idea, AR is like a screen you have already with in your hand. You just lay it on top of anything on that is flat enough, and you can see the virtual thing or the augmented thing, right? Not a virtual thing, that is an augmented thing that is programmed. So that is computer generated image, right? And also sometimes it is like you point out and you can click on it. You can have interactions. You can just see अगर एक map है तो map पे you're like click on it. You can see a building pop up. You could see a 3D view of the building. You could just move into it basement and all. So that can be also managed into a VR AR setup, right? So, but again, with the consideration being that the hardware is capable enough of doing that. So the use cases remain similar to VR, but additionally, we could also use it for retail, repair and maintenance, then for business logistics, and then for public safety. So I'll just cover these four because the other six are like pretty much the same for VR itself. So for retail, as we all know, we have lens card, right? So lens card we might have used. So you have the feature where you can scan your face, and then you could just select a frame and see in real life how it would look on your face. Right. So that is something AR does. So that is retail. Then for shopping malls or some shopping sites or stores might also introduce their app itself. So what will happen in that app is you can take that app, download it. You could just see at a mannequin, and then you just say that if you want to get that dress and see how it looks on you. So you could also do that in AR. So for business logistics, as we know, warehouses are pretty huge, and like carrying something from one place to another, people might get confused about the routes. So AR could guide them for that scenario where it could show the shortest route through the warehouse, right? So like if there is something that is to be delivered from one A point to B point, and if there are three routes to them, the AR could analyze and give you the shortest route that could go, because it has a built-in map of the entire warehouse or something that can be used like that. And also additionally, if we want to sort out some things and we are wearing AR goggles or something like that, and we have a device in our hand, so we could just scan over it and just see where exactly it is going to be and on which rack it could show. Like, so we just pointed at our delivery package, scan it, then just search for the rack that is going to be. So that is a very handy feature. Then for public safety, like if you are wearing an AR goggle or you have a AR device and you're very much comfortable with that, and you're wearing it throughout the day. Consider the scenario, not possible in real life, but consider it. So you're wearing it, throughout the day, and something happens, like there is a fire, or there's an accident, or there is something that is going to happen, or the AR technology might help the people who are wearing AR technology over them, like through AR goggles, or any devices that you're having. So they will be notified in the first instance, right? Because that is the easiest way that they could be shown. Like it could be a telecast, right? So you could take that thing into it. So we might also have seen movies where I also remember we have this technology used. So they have a goggle, only one piece of the eye goggle is there, and they have this interaction over there. So they could just see what is happening. So they could just switch around the recordings and all. So that is something that is possible through AI, and then MR also. So we'll just move ahead. So these are the use cases basically. Then AR experience setup. There's nothing fancy for an AR experience setup. Just you need is a hardware that is capable enough of handling the AR rendering and whatever features are coded inside a software. Like, so if your device is pretty much capable enough of providing you the experience, you can just get the experience inside your home with your normal devices as well. If the hardware is pretty good. So that is the minimal setup that you could need. So the basic requirement is you just have to firstly recognize a flat surface or something that is such a plain area that you could lay something upon it. Okay, so wherever you're pointing at, it could be a table, it could be a floor, or it could be a wall if you want to see a wall hanging and all. So we could just use that. So next we'll see design considerations for like AR. So as I said, firstly we just focus on this point where we have design for safety, right? So as we know the Pokemon Go game. So what happened in it was people were crazy about the game and people were crazy about catching Pokemon. They had this nostalgia running around that I want to catch the Pokemon and have the highest number of Pokemons. I want to upgrade them and all. So in that case, they were missing the sense of real world going around them, and sometimes they used to run around on streets, get hit by something. So that frequently happened. So firstly, while we are creating an experience that is such bound to human life, so we must take into consideration that people should also be reminded about the safety. So we might want to have some indication inside the app itself that will guide us that to check our environments on timely basis, like a period of time. Or we could just if we are using AR and we are just pointing out something, so it should have an ability to recognize, like if there is a pole, if there is a pit inside. So if there is something that we might stumble upon, so that should be shown up on the screen or the AR, and we should be able to firstly design for that thing. So next, as we know, we have interactions where firstly, as we know, we have interactions currently for the rectangular screens. Like, so we design for mobile phones, laptops, and all websites and all. So what will happen is, so when we are doing that thing, we take into consideration that we are only limited to rectangular frames. So currently, as we are doing this, so we should not limit in that case, because while in AR, you have a limitless boundaries. So we have like a 360-degree horizon open for us. So what will happen is if you are limiting to rectangular frames, we don't take into consideration the wide scope, then we might miss out on the experience that we want to immerse the user into. So that is something we want to focus on. Okay, so we just want to predefine the spaces. Firstly, as you can see, this is a graph where we want to show, like this is the intimate space that the person is standing into, and that's like 0.5 meters around him. Okay, that is his personal space. So that is a personal space that he is very comfortable doing any actions in it. So, and this will be the 4 feet distance would be the social space. And then we could see a public space. So while we are designing for like apps that we want to take into consideration, like for private regions and public regions. So we might want to take into consideration how it is going to show the interactions, like, so how far the interactions or the objects inside the AR are going to be placed for the person to be very easily carry out the interactions inside the app. Okay, and also while we are considering that, so we'll also consider physical constraints. As you know, that the setup is minimal, but it comes at a cost, right? So while you see we are tend to hold the phone for a longer time, we have fatigue, we have some pain in our arm or something like that, we have headache, something like that. So we just want to take into consideration that whenever we are designing for AR, so first thing we should take into consideration how long the sessions are going to be. Like for a private region, the user can do very lengthy sessions, or very interactive session where he might jump and he might hop and all. So but while in a public space, so should he be doing that thing? Because he doesn't want to gain the attention of people, because the AR might want him to get into that immersive experience, but that is not a right place to be at, right? So we should be considering how often the app are going to use, the AR apps are going to be used, and what would be the environment they are using, like the private one, the public one, how it is going to be. Okay. So that is something we want to consider, the physical constraints and also the usability testing. So as we know, like AR and VR, we have it. So testing is must. So we want to test the apps before they are released out, so that users do not have a bad experience, right? Exactly. So the primary objective of any app that is rolling out is that the user should be at ease, and he should not have any like hindrances while enjoying the experience and all. So that is the thing where that. And also during testing we might come across things that if the design considerations are taken or not, the safety is taken into consideration or not, the physical constraints are taken into consideration or not. So this all can be collectively organized and managed, right? So nextly, how an immersive experience can be created, right? So immersive experience can be created, as you can see, uh, by decluttering the UI. Like, don't give a lot of options. So as you can see in the GIF over here, so the person is just pointing at the table. It is recognizing it, and just he could just tap on the screen and just places that thing on the table, right? So that is that easy for AR to place things around in your house. Okay, so you just need a flat table or flat surface that it can identify, or that you should be able to give instructions and make him identify. So it would be in that way. Then we want to minimize the input, like too many options may overwhelm the user. So we might want to consider that we should give a minimal options, like if he wants to place something on a table, or if he wants to zoom in, zoom out, we should give a sheet primarily, or we could just give onboarding screens for that, right? Or we could just use audio. Okay. And using convincing illusions is something another thing, something that the user appreciates. Like for AR experience is to be more immersive, you want to use 3D assets of higher quality, right? So if that is close to real life, people will enjoy it seeing around. So what happened recently was while Apple were releasing it, I guess the new CPU that came out, it has the great kind of structure. So what they did was they pushed this thing on every iPhone, that they had this ability to view the CPU that was going to release before the release. So what people are doing, that they were just finding a flat surface, getting it into the thing, and they were just tapping on it. So it could give you a full view. You could just zoom in, zoom out, have it at whatever length you want, or whichever place you want it to be. So that was their marketing strategy for making people feel the luxury of their product at their home. Like so people usually did find it amusing, and they started placing like the CPU images on their tabletops or like counter shelves and on the floor and all, and they started imagining their setup how it would be. So eventually that sold out, but the design was not appreciated that much. So you know that. So that is the thing. So that is one thing, and then we have the onboarding experience. Like, so onboarding experience is like the primary feature when it comes to extended realities, because people are getting into new thing. So people might want to get the acquire required attention, and people want to learn new things. So it would be a rather a steep curve for them. So we just want to make it easier. So that is what we want to do. So for, as you can see in the GIF, so there is a fox inside it, and it is showing the interaction. Like, if you want to go in that direction, you should go there. So we also have the arrows pointing above, and also have the fox who's guiding us. So this is something AR does. So we could have this thing, and this is a way of guiding the user visually, right? So, and inside the app, as you know, that is again a mobile app or a tablet app that you use throughout the day. So the UI patterns that we follow throughout other apps that can be used similarly for these apps as well. So like scrolling, zoom in, zoom out, pinch in, pinch out. So वो सब यहाँ पे use हो सकता है. And so it is similar to creating a mobile experience, but considering the fact that it is going to be an augmented reality setup, right? So this is something that we want to consider for onboarding. Then onboarding can also be done in this way. So for like, we could just give instructions at the starting of the app, like the onboarding screens. So we want the user to identify the flat surfaces. We want it to be like this, and then we can just start with it. Okay. And this is an example of how IKEA does it. So firstly, AR design is pretty much influenced by the fact that it has a clear business idea and a clear user goal, right? So business idea of IKEA was to have people place furniture around their home and take a look and feel about how it would look in their living room, what color they want it to be, and all, and how would be the placements and all. So people really appreciated this product, and so the business goal was clear, the user goal was clear, how the user is going to use it was clear. So that made a huge success for them. So this also drove people after they had the screenshots and everything. It was easier for them to go to the store and just buy that. I want to have this color and I want to have this for my living room, my bedroom, anything they want it to be like. So so taking into consideration how AR works is you should have a clear business idea. If you're working for retail, like so for retail example, like you're creating apps for like big industries and all. So in that scenario. Then we'll move to like aspects of AR and VR. Like, so what are the major differences? So firstly, as you know, AR is now you're much aware ki it is a full environment around you. That is a 360 view, and that is inside the VR glasses or the VR headset that you're wearing. And AR, on the other hand, is something that you can interact with, and that is laid upon the over real world. Like so, through your app or through the AR goggles, as you can see. So this is something that we want to take into consideration. Then the 4.8 was the interactivity. So the interaction should be pretty handy enough. The user should not be overwhelmed with interactions, and also that is something we want to consider. Then user should believe that he's inside the real world. Sorry, inside the virtual world, and he should compare his living inside the virtual world with his living inside the real world. So that is the difference we want to break. So we want the user to make himself believe that he's inside the virtual world for a longer time and he is enjoying the experience. Like, and we don't want to limit him to only a certain view, a field of view, and we might want to explore, or the user might want to explore the areas. So we should allow him to be around. We should design it in a 360 way. So we should design it in a way that the user is allowed to explore the thing completely, and making it immersive is the most primary thing. So we could give like haptic feedback, then we have sound, then there are a lot of things. So we could just use that things to make the experience immersive enough. Okay. So on the other hand, also these things are applicable for AR, but along with that, the other things that are pretty much important and pretty much securely overlooked are environment. Like so, the environment that we are living in and the environment that the AR app is going to work upon. Like so, that should be identified primarily. Then for safety purpose, as we said, there should be instructions for like watch out for safety, or we could just give regular pop-ups like look out for something this and that. So we could have that. Then keeping it simple. So the VR and AR are two different categories. So VR can have complex interactions, like cause that is inside a real world, sorry, inside a virtual world. So we could just have interactions and that won't affect us. But on the other hand, if you're having a complex feature inside AR and if people find it difficult to handle or something like that, so they might not want to use your AR technology or your app, right? So that is something, and we should make them comfortable while using that. So that is the whole thing. So this can be used interchangeably because simplicity and comfort also can be used for virtual environment as well. So, but considering the fact that in the real world we are using augmented reality and we're laying things upon the real world, so safety is the safety environment are the primary things that we want to consider over here. Then we have a bonus. So, so for this thing, so how many of you guys have seen this epic scenario where Tony Stark is doing all these things with his hands? hand. At least give me a number, like how many people are there in the audience, like who have this thing. I know that there may be like 70-80% of people who already have seen Marvel, who already know Iron Man. So taking the factor of consideration that what is he doing there? So can anyone identify, is it related to AR or VR, or what is it exactly? Anyone?
AR.
Okay. Another guess? Anyone? So take into consideration the fact that AR and VR require something in front of you, right? So you should be seeing through something. Okay. So that is a fact that you want to take into consideration. He might have some lens put on him, so that you can also consider. But this is something that we are going to see in the next slide. So this is a combination of AR and VR. What we call is MR. That is mixed reality. So this is something that we could see the 3D objects right around him that are usually used extensively in virtual reality or creating a virtual world around him, right? So he could interact with them and all. And alongside, he's also laying that upon the real world. So this is AR, right? So AR and VR are used in a fusion. So this is MR. So what is happening over here is you could see a person who is wearing HoloLens, like this is a Microsoft product. So that is the closest to MR experience that we get in the market currently. So what is he doing is he's currently having a 3D rendered model of a chair. He's just zooming in, zooming out, rotating it, and having that view. But what is he doing is, so he's wearing the HoloLens, that is the MR goggle, we could say, in other sense. So what is happening over here is, so there are two cameras over there. Okay, so it is set up like this. So it has cameras over here, so that detect like the environment around you, and these goggles are the AR goggles, right? So or the VR goggles that you could say that are used to render 3D objects upon your screen. So this is your screen where you primarily see everything, and these are the cameras that help you get the augmentation in place, right? So AR and VR combined, it gives a HoloLens setup that Microsoft has prepared. So this is something that is currently in trend, or people are currently trying to get into use with. And as we know, this is a fusion of both like AR and VR. So design consideration wise, we could say that the design considerations are pretty much similar to AR and VR itself. So we could use this interchangeably. The design consideration that we took for VR and AR can be used alongside with MR also. So if you're designing for experience for like MR, so same like the distance that we want to maintain, like 1.5 meters away from the screen, we want to see that. Then we want to make it a closer experience. We should take into consideration that if it is a personal space, social space, and then a public space, intimate space, what is it going to be like the experience, right? So with all that considerations into taken into consideration, and then we also have the safety factors and all, because this is also AR itself, but with a bit of VR in it, so a virtual reality. So safety also comes handy. So we'll have to take care of that as well. So this is something we want to see. So the Microsoft HoloLens, and then we will see the use cases. Like, so what use cases or what areas this is used in. So pretty much the same, like VR and AR are used in areas where surgical training, and then for repairing, maintenance. Then we have seen it is for employment purposes, training and all, gaming and also similarly this can also be used. So I'll have just a few snaps of it, like how it could be used. So firstly, you could see this girl is rendering a 3D bike on her computer, and then on the other hand, she's also wearing a HoloLens, right? So you could see that the 3D rendered model is shown on her desk right here, and she has the buttons over here. So for like rotating the model, like if she wants to zoom in, zoom out, whatever interaction she wants to have, that she can have inside it. Okay. So the first point that you want to consider is that we don't have like controllers over here. So for VR, it is a very crucial step. Like if you don't have controllers or the joysticks, you won't be able to control anything inside, and your interactions would be vague, right? So So what will happen is for AR also we need a screen where we want to just touch and then focus and whatever we want to do. But with HoloLens, what happens is you're wearing that thing, right? So whatever you're doing with your hands, like interactions, you're pinching in, pinching out, zooming in, zooming out, whatever it is. So that is detected, your hand motion detected by the cameras that are put on. Right, and that is then converted into interactions for the rendered virtual reality, and those are applied over that. So this is how MR works. And in the second case, we can see that a dad is providing instructions to his daughter, who is fixing the sink, right? So what is happening over here is you could see that the dad is just drawing on the tablet, right? And that is being shown inside the IMX reality goggles, that is the HoloLens, and that is shown like this should be fixed in this direction, and this should be twisted in that way, right? So this is what MR experience might look like if you are using it in a real daily scenario. So that is it. Yeah, that's the wrap. Thank you.